Alrighty, folks, it's Mr. Walker here, and we're back with part two today. All right, we're talking about dilations this time on the coordinate plane. All right, so first off, how do we go through and deal with this? When we're dealing with dilations mathematically, we are either multiplying or we're dividing. So if we got a point and we are dilating it, we are multiplying the x and y of that point by whatever the scale factor is. That's where this k is. Remember, k is what our scale factor is going to be denoted as. So just make sure that you're aware of that going forward. All right. So first thing that we got is we have an example with dilating with the center of our dilation being the origin. Remember, the origin is 0, 0, right in the middle. So we're going to be dilating triangle RST to R prime, S prime, T prime. And we are dilating the original shape by a factor of 1/2. All right, let's go through and graph our first shape. So we got R at -4, 4, S at -6, -4, and T over here at 4, 4. So let's go and connect those. Now, when we're dilating, we have to take the scale factor, which is 1/2, and we are going to multiply each of these points by that. Now, if you multiply each of these points by our scale factor, you're going to notice that the new points are going to get closer to our center of dilation. Okay? So, our first point that we got here is R prime. So, when we multiply both of the points for R by 1/2, we end up getting -2, 2. Now, here's R prime right here. Now, if you notice, the original one was far out, and as we're making our new one, it's getting closer to our origin over here. So you should see that these two are also going to follow suit. Let's go through and look. All right, next one we got is S prime. S prime is -3, -2. Now, that's because we got this negative and negative here. Make sure that you keep up with your negatives as you deal with your dilation. And these got closer to the origin over here. Now we got T. T gives us 2, 2. And here it is, getting closer to our point of, sorry, not our center of dilation. My fault. So just notice that all your points here should be getting closer to the center of dilation. All right. Now, if this were a larger scale factor, that means that they would be getting further away. But as long as you know the points for your original one, you can go through dilated as you need to do. Okay. All right. Let's get into what if it's not at the origin for our center. So, if our dilation is at a center, not at the origin, we have to go and be a little more careful with this. So, we have to observe the vertical and horizontal distances from each vertex of the figure to the center of the dilation. And we are going to count the slope. Now, if you remember slope from Algebra 1, slope is, let me go through and just write this over to the side. Slope is the rise over the run. Rise meaning up and down. Run meaning right and left. Okay. So let's go through. Let's take a look at what we are going to be graphing and where our new center is. All right. This next one we're graphing triangle ABC and A prime, B prime, C prime. And our center of dilation is -1, -2. And our scale factor is going to be 2. All right, first, let's go through and graph A, B, and C. So first we got A right on the x-axis at -3, 0. We got B up top over at -3, 4. And then we got C over here to the right at 2, 1. So here's our triangle. Now, things to note. Our scale factor is 2, which means that this is going to get bigger. And our center of dilation is not 0, 0. It's -1, -2. So first, let's go through and graph that. Here's our center of dilation. Now we want to go through and deal with some of the changes. So we're going to take our scale that we got here, and we're going to go through and affect some changes. All right, first off, let's look at A. A is at -3, 0. When I get A prime, you might notice some things happen to change. Why is it over here as opposed to me just multiplying my point? I'm not going to multiply the points this time. I'm going to be multiplying the slope by our scale factor. So let's just observe real quick what the slope is. Let me get the pen. All right. Now from A to our center, we go down 1 to the right, down 1 to the right again. So this right here, this red line, that's our slope. Our slope for this was -1 over 1. -1 because we went down, and 1 because we went to the right. Now what we're going to do is we're just going to double that slope. So doubling that slope is still going to have the same fraction. It's still going to end up reducing to -1 over 1. But if we multiply all this, this would be -2 over 2. So I'd have to go up 2 more. Well, sorry. Yeah, I guess it's going up in the reverse. Sorry. And up 2 and to the left. And that would get us to our new point. So this point here, A prime, still has the same slope, but the distance that we took was just doubled. All right. So this right here, that's our new one. Now we want to observe the other 2 points that we have going on here for B and C and look at their slope and then go through and figure out how far it's going to be. All right, let me go through. Let me get another color here. Let's get blue. All right, so looking at B to our center, B is at -3, 4. Our center of dilation is at -1, -2. So for me to get from here down to there, let's go through and count our blocks. So we got -3, all comes down to -1. So this comes to the right. So our run is going right too. Now, what about our run? Our run, we're going from 4 down to -2. 4 to -2 is going to give us 6. So our slope here is 3 over 1. This distance here is going to just be doubled for everything that we did. Okay? So we're just going to follow just like how we did before and go in the reverse. So we're going to go up 6 more. So 1, 2, 3, 4, 5, 6, and over 2 more. This right here should be where my new B is at, hopefully. Okay, so let's see. All right, there's B. Perfect, perfect. All right, so we got our new B up here. Let's look at C. Let's go get this in another color. Sorry about the noise in the background. That's the AC. So C down to over here. Our run, since we're going to the left this time, is going to be negative. So we got from C, this is 2, this is -1, so this is -3. Our rise is going from -2 to +1, which is +3. So this has a slope of going up 1 and over, up 1 and over, up 1 and over, So our slope here is -1/3. Actually, this is actually be +1/3. Let me fix that. I realized I was counting backwards. Sorry about that. So this is actually going to be a +1 for this. So if that's the case, we're just going to follow along the same pattern that we had before. So let's go through. We're going to go follow the original slope. So let's go over 3. So 1, 2, 3. And let's go up 3. 1, 2, 3. And that should bring us right up here, making that my new C. All right, let's see if I was right. Okay, there's C. All right, now these 3 points here, A prime, B prime, C prime, are located right over here. We got -5, 2. We got -5, 10. We got 5, 4. And those connect up and makes our new image. Now, unlike our previous one, it's not going to be us multiplying straight to the points. We have to multiply to our slope so we can find our new shape. Okay? It's going to take a little more, you know, work. I don't want to put it like that. It's going to be a little more detail oriented. So take your time with stuff like this. We'll do a little more practice as we go through, and hopefully you'll start getting used to it. Okay? All right. So here's what we got. We got 2 on the bottom here. You got 2 shapes, one on the left, and we got one on the right. On the left, we got the following graph, and I want you to go through and find the scale factor. And for the one on the right, you got same type of deal. We're finding the scale factor, but this time our center of dilation is going to be -5, 3. So I'm going to try to do these ones together because I know it's going to be quite a bit. Okay? All right, let's go through. Let's note some stuff here. All right, let me get a pen out. All right. So over here on the left one, let's do this one first. Our center of dilation is right here. Oop, don't want all that. Our center of dilation is right here in the center where X and Y cross. So that's our origin. For us to figure out what our scale factor is, let's take our corresponding sides and let's make a ratio. So we are going from XYZ, which is our larger triangle, to X prime, Y prime, Z prime, which is our smaller dotted shape. All right, what you're going to do is let's look at one of the sides here. Let's look at YX and Y prime X prime. So Y prime X prime is, well, let's see, this is 1, 2, 3, 4. All right, Y prime X prime is 4 units. Now let's look at YX. We got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. This is 12. All right, so I want to go through and figure out how did I get from the original to the image. First, we want to look. Did the shape get bigger or did it get smaller? It got smaller. So if it got smaller, that means that we need a fraction. This scale factor is going to be less than 1. So we're going to take our image and put that in the numerator, and we're going to put our pre-image, which is our original shape, in the denominator. So if we're doing this, that means that we got 4 over 12. Now what we want to do is we just want to reduce this. So let's go and reduce it. What is this going to be? Let's get this. Let's get us a little bit of space. Get a little space. All right, 4 and 12, you can both divide those. And when you divide them both by the same number, you end up getting 1 up top and 3 in the bottom, because you can divide both of those by 4, which means our scale factor is 1/3. So yeah, you just got to go through, pick one of the sides. You should be able to go through and do that. If you don't have a horizontal or vertical side like how our shape does, you're going to probably end up having to do the distance formula, but I'll warn you ahead of time when we have to do that. Okay. All right. For this last one, I'm going to leave you to try out this. Okay. I'm going to get this as one of our practice problems. So I'm going to catch you guys later.